Welcome to Brain Vision.
For the first 5 seconds of motion, we have that v naught is equal to 0. The time elapsed is 5 seconds. And so we can determine an expression for the final velocity in terms of the acceleration by using v is equal to v naught plus a times t. And so if v naught is 0 and t is 5, then we get v is equal to 5a. Now, the next key idea is that this final velocity of the first 5 seconds is equal to the initial velocity of the second 5 seconds. And so for the second 5 seconds of motion, v naught is equal to 5a. T is still equal to 5. And we're told that x minus x naught, the distance traveled, is equal to 200 meters. So we can use the kinematic equation x minus x naught is equal to v naught t plus 1/2 at squared. And x minus x naught is 200, so I'm going to plug in 200 there. V naught is 5a, and then t is 5, so I get 25a for that term. And then t squared is 25, divided by 2 is 12.5a. And then I can solve this for a. And I get that a is 5.33 meters per second squared. Now that we have a, we can go back to the first 5 seconds. And we can use x minus x naught is equal to v naught times t plus 1/2 at squared. Our unknown is the distance traveled in the first 5 seconds, so we're trying to solve for the left-hand side here. We know the initial velocity for the first 5 seconds is 0. We now have solved for a, and we know t. And so this is just equal to 1/2. A is 5.33, and t is 5. So we have 5 squared. And then when we solve this out, we get 66.67 meters, just meters. And that's the distance traveled in the first 5 seconds of motion. You'll notice that it travels farther in the second 5 seconds because it's sped up by then. And so this makes sense with our intuition that this should be smaller than the second 5 seconds distance. And that's the end of it.